So recording is underway, and got one more person to add in. Okay. Um, so you did chapter 13 last week, and that was a relatively fast, it was a fast session. We're on 14 this week that we'll be doing, and we're looking at the transport layer, which has got a good bit of information in it. And I am doing this front house again so that hopefully the quality is good and that y'all can all hear fine. It's showing quality good. So we're going to be looking at the transport layer, which we'll be looking at two protocols in this chapter. We'll be looking at UDP and TCP. Now, before I start on that and start into those, are there any questions on previous material, what's happening, etc.? And then y'all can ask questions during also as we go along through. So it's not saying you can't ask questions then. I'm just making sure if there are any questions that I get them covered. All right, cabling continues this week. I've got it on Wednesday and Thursday this week. Thursday, I believe, is on Walker campus, and then I've said all day that day. Yeah, and then Wednesday is at the Catoosa campus from noon to 3 o'clock. So be aware of those if you haven't done it yet. And if that doesn't work, and if you will let me know why you didn't make another session, because I set up those sessions completely on what students turned in requests for. Let me know on that, and I'll try to set up some times next week to do the last ones on it. But you'll have to let me know why you missed a session, didn't make it to any of the sessions, and same thing as I originally requested. I'll need to know what are times, days, time of the day, days, and campus that's going to work for you. But Thursday, I will be on the Walker campus all day, doing them from about 9 in the morning to 4 in the afternoon. I will take lunch at some point. So if you're going to come somewhere between the 11 and 2 o'clock range, do send me an email beforehand telling me when to expect you so that I will definitely be there, because I will go to lunch at some point and I'll go in that time period. And if there's students that are going to come at a certain time, then I'll plan my lunch around that. But I do need to get lunch each day. So we'll be finishing up on that. We've basically got 3.5 weeks left in the semester at this point. So we're coming down to the end. This won't impact y'all listening live today, but somebody could listen to the recordings. I hope to get those moved out there quickly like I did last week. Tomorrow I will be, well, it will affect you in one way. Tomorrow I'll be off campus with Leadership Walker again, and that'll be an all-day thing. I have to meet them at 8:30 in the morning, and we go till 4:15 or something in the afternoon. So that's a full day. And then, so the collaborate sessions for tomorrow will not be tomorrow. They'll be on Wednesday, but I'll be doing those somewhat, well, the morning ones will work. I'll do them from Catoosa probably, because I've got it from 12 to 3. But the afternoon one will overlap with the cabling people. So if you show up later on the cabling that day over there at Catoosa, You may have to wait a bit for me to demonstrate stuff to you or to check stuff off, because I do have those sessions tomorrow. This one, the afternoon one. So those will be on not tomorrow, but Wednesday. Normally they're on Tuesday, but they'll be Wednesday this week. I will go ahead and tell you all this much too. In 2 weeks, I anticipate moving Monday sessions to Wednesday, because I will be in Greenville, South Carolina Monday night for Eagles concert. And I'm not sure, I'm going to be online some that day, but I'm not sure where, exactly when I'll be able to be online, etc. So I'm probably going to move those to Wednesday that week, but that's not definite yet. But tomorrow I will not be answering email during the day. Grading wise, I'm just about caught up on that. In your class, as far as what was turned in that was due before today, basically I've only got one thing. I think I just noticed I just graded a few more items. One item that came in at the last minute before the deadline to grade, and then one late assignment, and I think that's all I got to do is catch up in this one. In another class, I've still got about 4 or 5 items to grade. And in another class, I may have a few items in there that are left over from last week to grade. So I'm fairly close. However, tonight I'll have a whole big pile of new stuff to grade. So I'll be working on that this week also. So I'll do my best on catching on all of that. I'm also trying to start transferring grades from the 2 systems, between Netacad to Blackboard and Blackboard to Netacad. So those should start appearing in the 2 places. If I don't have your permission form yet, I need it ASAP. Because you will not be able to pass the class if you do not get me the permission form. I'll also remind you, as we're coming down to the end here, the lab final, which you'll do on Packet Tracer at home like the others, which I believe is available out there now. I'll have to double check on. I'm pretty sure I made it available. You have to do it to pass the class, and you have to do the final exam. Now, I didn't say a score you had to make on those to pass the class, but you have to do them. That's a Cisco requirement. I will note this: the practice final is out there at Netacad now. So on the transport layer, you're really looking at how it's going to send the information across, and that there's 2 protocols on this layer that you're going to be dealing with. There's other protocols on this layer, but these are the 2 primary ones that are used out there, and they're the 2 that you need to know in terms of transport layer. There is the UDP protocol, and there's the TCP protocol. UDP is user diagram protocol. TCP is transmission control protocol, sorry. And TCP gets used into the name of the whole suite of protocols. But TCP says that when we send stuff, we know it gets delivered. UDP says basically that we're just sending the stuff and assuming it gets delivered, but we don't have a confirmation on it. So the transport layer is going to be dealing with that. So here's another term to watch for on transport, is that it's talking about data flow. How do we get the data from source to destination? So data flow is going to be a key term about the transport layer. So if you see some question that has something about data flow on it, look for transport layer. Now there is some data flow stuff done on other layers, but the primary place you'll see data flow mentioned is on the transport layer. So they're going to take you through on that. They introduce to you the 2 protocols for you. And with TCP, when you send something, the machine is going to get an acknowledgement back from the other machine that it was received, and we're going to see how that all gets done in the process. But your machine is going to know that what it sent out actually got delivered. UDP just sends it. It's a connectionless protocol. TCP is connection oriented. To use a real world illustration for you, not on computers, UDP is like when you mail a letter. You drop it in the mailbox and you assume the post office will get it delivered to wherever it's going. That's UDP. TCP could be related to the telephone, but I'm going to relate it still to the post office to a different level. If you send that letter registered instead of just putting a 55-cent stamp on it, and I think it's 55 now because I buy my stamps 100 at a time and I get the forever stamps. So if the price has gone up since I last bought stamps, I'm not really aware of it. But I go to buy the next roll of stamps, I'll be aware of it when I write the check for it. But TCP is going to be the other one you can relate UDP to is it's like radio or TV. The announcers don't know whether anybody's actually listening to them. They're hoping they are. They think they are. But there's no way of knowing are people listening and hearing what they're telling them. So they're sending it out, but there's no way that we know exactly who all listens or anything or how many listen. TCP will be like sending a letter registered. You go and it gets sent to where it's going, and you pay extra money for it, and you have to fill out a little card that gets attached to it. And when it gets to where it's going, the person that's receiving it signs for it, and that card comes back to you, and you know that they received that letter. Likewise, telephone call. It is like TCP. You call, you know you're talking to the person. You get confirmations from them in the conversation that they know what you're telling them. And then you conclude the whole thing. And we're actually going to relate it a little bit later on as we talk about how TCP operates to that telephone call. If you got to make sure it gets there, you got to use TCP. If you're just sitting it out and if part of it gets lost, it's the receiving machine's responsibility to tell the other machine, I'm missing some stuff. So you're going to use both ways. But TCP is going to establish a session. It's going to make a connection to the other machine so it knows the other machine is there. And then it goes through and makes sure that the information is delivered and that it's delivered in order. And we're going to see the process it uses to do that in just a second. So it's doing flow control in it, that it's making sure everything gets along to there. The TCP header has a whole lot of information on it. So it's going to have the ports, what ports it's coming from, what ports it's going to, because we're going to see that mentioned as we get on to the end of the chapter about port numbers. It's got a sequence number on it because these have to be received in order. It's got an acknowledgement number. The sequence number and the acknowledgement number is, the acknowledgement is we did receive it, and there's a way we'll see how it tells us on that. And so it talks about window size in the header too, but we're going to talk about window size in just a little bit when we talk about how it sends it. So I'm not going to give you that information. Then it's got a checksum on it. UDP has a very simple header. It's got the source port to destination port. It's got the length and it's got the checksum, and that's all that's on the header. So UDP has a lot less to it, which is an advantage to UDP. It can get it there quicker. So then they mention to you also about some of your applications that are going to use TCP. FTP is one you always see mentioned in terms about TCP usings. Definitely be aware of that one. SMTP is going to use it also. HTTP, oddly enough, uses TCP. I've always thought it should be using UDP, because if you send a web page out to somebody, if it's missing a few little pieces, it's not going to make any big difference, but it does use TCP. And that, so they use several different ones on there. And then SSH would also use TCP, because that's where you're doing the secure passing across information. UDP is used for some other type things. Applications that make sure they arrive anyway can use UDP. Now, we said FTP uses TCP. There's actually also an FTP, TFTP. I forgot what the first letter was. Trivial FTP, for file transfer protocol, which uses file transfer program to do it. But TFTP is where you're sending files without making sure they actually arrive. Main place you're ever going to use TFTP is when your computer is directly connected to a router or switch, and you're transferring files onto that router or switch. Well, you're directly connected to it, so you'll send it across with TFTP, because you can tell if it all got there or not, and you know it will, because it's really not going across the network. If you're going to send it across the network, you usually should be using FTP. So they go through and show you a number of those. DHCP will use UDP, SNMP, which is your network management protocol, as opposed to the mail transfer protocol that we said is on TCP. Those two always mix me up on similarity of the letters of SMTP, SNMP. Forever since I started in networking, mix those two up. DNS will use it. Voice over IP uses UDP. Reason: voice over IP uses a lot of bandwidth in the first place. Second thing is, we can a few bits can miss on it, and conversation goes right on along. Because just like when you use regular telephone over the telephone wires, there can be things you'll see missed, and sometimes it gets too bad and you have to tell people to repeat. But live video multimedia applications are going to use UDP. It's less overhead onto them, and that missing little bits in it is not going to be significant. And so you can use UDP to do that, and so that's what you'll use. Port numbers. Port numbers are going to tell us what application is this associated with, this message. There are 62,000 port numbers, if I remember correctly. And so you're going to tell it what port are you sending it from and what port is it going to. The source tells you what's the application it was associated with on the source machine. The destination tells you what applications it's going to be associated with on the destination. Now, for security purposes, you may actually change those port numbers around some and do some switching of port numbers so that you can make it more secure on it. They mention about socket pairs. That used to be a lot more used out there, that you saw about sockets, where you don't see sockets quite as much mentioned today. But the socket pairs is where you've got the source port and the destination port associated between the two of them. But sockets will actually be your IP address and the port number. And y'all may have noticed when you go to some websites that you actually put on the end of the address for it, colon, and a number. That is the port number you're putting on the end. Well, web pages by default use 80, so you don't have to normally put the colon 80 on there. But if you were using some other port on it to keep people from as easily getting into them or whatever, you would have to put that port number following a colon. And that's considered a socket on it, where it's the IP address with the port number. So do be aware of those. On that, port numbers, they tell you they come in groups. And I didn't tell you enough port numbers a moment ago. I was close, but off a little. Well-known ports are 0 through 1023. And those are ports that have been predefined out there by the Internet authorities that gave these ports to certain things. Registered ports go from 1024 to 49,151. If you wrote an application and you wanted it to use a certain port, which a lot of applications do, you can register that port to use. And there's a payment process, and then that port is registered, and that's what it's supposed to associate with. Those change all the time, that people are adding and removing them. And then there's the set from 49,151 to 65,535, sorry. And those are private or dynamic ports is what they call them. Those ports are not assigned and kept out there on a worldwide scope. You can use any of those ports as long as nobody else, any other application on your machine is using those ports. So you'll see those ports quite often be used when you want to change stuff around. 3389 is remote desktop connection. That gets you into somebody's computer. Well, instead of using that port number, if you were to change remote desktop connection to use a different port number, maybe 1989, you could go in and change the port number it's associated with. And then whenever something came into your machine, it would know it belongs to remote desktop connection anyway. So you can work with some other things on these. Now, you need to be aware of some of the well-known port numbers, like they give you on page, well, y'all don't have a book, so I can't tell you the book. It's in table 14.4. I'm going to tell you which ones of these, they give you a long list here, and I'm going to tell you which ones you really need to pay attention to, and then which ones you don't need to know quite as well. Okay? So they mention, first one is they mention 20 and 21. There's about 3 different applications out there, and I'm trying to remember the others, that use 2 ports. FTP is the dominant one of those. It uses ports 20 and 21. 21 is used to send the control messages back and forth on it as it's sending stuff. 20 is used to send the data. Definitely know 20 and 21 belong to FTP. 22 is for secure shell. I've not really seen questions on that one yet, but I would think they would appear. 23 is Telnet. 23 you should definitely know. I see questions about that one appear all the time. That's Telnet, which is your unsecure sending stuff across. It's not encrypted. You don't want to use Telnet anymore. You want to use SSH, which uses port 22. So I think at this point in time, I would tell you to know 22 along with 23. And I'm thinking, when I took Security Plus last week, 22 was on there. So yeah, no 22. All right, 25 is for SMTP, for sending mail. That one will pop up quite regularly for you because that one's been around forever. 53 is DNS. I've not seen that one very often, but if you go use Amazon Cloud Services, AWS, their stuff about DNS uses their program called Route 53. Well, DNS is for routing your stuff across the network. So there's the route. And 53 is the port that DNS uses. So then you can remember that one. Then 67 is for DHCP. Actually 67, 68 are DHCP. So there's the second one that you'll see, 2 ports on it. I've not seen many questions ever on that one. So that one I really don't put too much onto. 69 is trivial FTP. That one, because of its number, and I'm not going to go into any of that, that number out there in popular, regular usage of people on the street, gets attention sometimes. TFTP uses 69. 80, you definitely need to know. That's what your web pages use, is 80. HTTP uses port 80. Port 443, I'll go ahead and mention that one to you because that relates to this. That's secure HTTP, remember, and that uses port 443. So you need to know that one also. Port 110 is for POP, for receiving email. POP's not really used hardly anymore, so I really wouldn't worry about 110. 143 is used for IMAP, which is where you get to work with your emails on the server from your PC, and they all stay right there. I've not really seen much question about 143, but you definitely do need to know what IMAP is, which we covered earlier in the book. And then 161 is SNMP, and I've really not seen questions on that one. Now, there are tons of more ports associated with programs, but these are the most common ones on them. So be aware of that. Netstat is a neat command, and if you take any security exams, you definitely need to be aware of Netstat. Netstat will tell you what all the ports and protocols that you are currently using on your machine, and it will return that information to you. That lets you know which ports are open, which ports are in use, and you can catch things security-wise that are occurring with Netstat. I will mention one other to you right now, also related to it, is Nmap, which is not in the chapter, but I'm just throwing this in as an extra. Nmap will give you some similar information, and that's a critical one to know for those of you that are going in the security field. All right, the next part gets into the TCP communications processes. UDP, there is no communication process. It just sends it. So UDP is real simple on this part. TCP is where it gets much trickier. We're doing good time on this one. And I don't have my little tablet with me here. So I'm going to go to the whiteboard on here. Because I want to use their whiteboard to illustrate some of what I'm going to talk about right here, about these different processes, about how we make the connection, and then about the three-way handshake, which is one you've got to know. So hopefully y'all can all see the whiteboard at this point. I wish I had my little tablet thing with me, because that draws a whole lot better that I used back when we went over subnetting and number systems and stuff. But here we're going to be sending from, whoops, I gotta click the pin first. And then we're going to be going from a host machine. So I'm going to draw myself a little host. And then we're going to be connecting to a server. So there's my server. So we've got a PC and we got a server. And we're going to be connecting using TCP. Remember, this is all TCP stuff we're doing right here. So to make the connection, what's going to happen is this machine is going to send to the server a connection request. So it's going to make a request for a connection. That's going to be a SYN sent out. Actually, it's going to be a hello correction. So it's going to send, actually it does send an SYN. Are y'all not seeing the board? Okay, y'all should be seeing the board because I'm sharing it on here. So that should be popping up for you on there. I'm not sure why you wouldn't be seeing it. And let me look here. All of y'all are showing good connection through, so y'all should be. And I see several other people have joined in. So it's going to send a sync connection. Now, I've done this as a PC and a server. It can be any two machines because you could be talking PC to PC. It doesn't care. This machine is going to respond back with an acknowledgement. So it's going to send an ACK packet back. Actually not a packet, but it's going to segment back on it. So it's going to acknowledge back. And then this machine will send an acknowledgement back that it received the acknowledgement. Now, if that looks confusing, it really isn't. Think about when you make a telephone call. If you were to call me, this is you, this is me. You'll pick up the phone and you'll dial my number. And my phone rings. I answer. That's when the acknowledgement comes back. So you hear hello from me. And then you're going to say hello back to me, which is the second acknowledgement. And then at that point, the connection is made. So it's really setting up the same as, I want to make sure I got everybody, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So it's working the same as on a telephone call. Have y'all got questions on that, of how that works? So those that aren't seeing the page, you may try refreshing. And I do know on 24, that's a problem sometimes in the classes that I'm taking, that I've been taking on certifications on how to teach them. That sometimes if we're not seeing something that's supposed to be on the screen, their recommendation always to us is refresh and see what happens. And that'll probably get it taken care of. Try your refresh on it, of refreshing the page there in your browser, which also usually F5 will do for you also. All right, any questions there on how it sets up the connection? If not, I'm going to go to the eraser and hopefully just erase what I want to erase. And I am. Neat. I also did pretty good on following across on the line. The next part is the three-way handshake. And all I'm doing right now is erasing because I see that we had somebody join back in. hopefully they can see the screen now. So now what we want to do is we're going to look at the three-way handshake. Let me do that. So I'm going to label this. Actually, that was the three-way handshake I just showed you. Correction. That the three-way handshake established it. So sorry about that. Okay. Let me erase off what I just started writing there. So what I went through and showed you was the three-way handshake, and you noticed it had three pieces to it. One, that there was a sync signal sent, and then there was two acknowledgments. Acknowledgement from B machine to A, and then there was an acknowledgement from A back to B. Now, what we want to look at next, well, we'll go ahead and look at termination. Guess what next thing they show, and then they're going to go through and talk to you about windowing, and then we'll talk that one. So then when it's ready to disconnect on it, you're going to use their termination process. Okay. Now, either machine can start the termination. It doesn't have to be the one that started the whole session. Either one can start the termination process. Just like on a phone call, that I can be on a phone call with Whitfield, and that I could have called Whitfield, but then Whitfield may decide we've done all the talking we need to do, and Whitfield can start the termination, or once I tell him what all I want to tell him, that I can start the termination. Either way. So on this, so these machines could be flip-flopped, is what I'm basically trying to tell you. Whoops, I knew something didn't look right there. Is that there's going to be very first is going to send that one machine is going to send a finish signal, an FIN signal, which is telling the other machine, okay, I'm ready to quit at this point. That's like on a telephone call that this machine has just said bye to the other machine. Now, the other machine will respond back with an acknowledgement. It receives that. And it's going to also say bye. It's going to send a finish signal too. So the FIN is the bye. The other is just acknowledgement that it did receive that signal. So then this other machine, when it gets the finish back from this one, it will acknowledge that it received the finish, and so it will send an acknowledgement also. And then they disconnect. So there's bye, and this one's sending back that it did receive the bye, and it says bye, and then it acknowledges I received a bye, and they disconnect. Now realize this one could send a finish. This machine could say I'm not finished, and it could send an acknowledgement, but not send a finish signal, and so the conversation continues. Okay. Now, let's look at windowing. This is really going to be probably the hard one for y'all. At least for most people it is. And hopefully with my relating it to a telephone call, that these other two things make sense to you about how that process is. And notice it is completely connection oriented between those two, that both machines know the other machine is there while they're sending this information back and forth. Just like on a phone call, you know that the other person is on the phone with you while you're talking to them. Okay? Versus you send them a text, you don't know whether they're reading the text or not. So texting is like UDP. So now what we want to look at is windowing. With windowing, the first thing the two machines are going to do is they're going to, and this is after the session is established, then what they're going to do is they're going to establish what window size to use. So machine A is going to send a message to B that says, I want to use certain size window. B is going to respond back of, okay, that's an okay size, or no, I can't handle that big of a window. Now, what the window is how many segments are we sending across before we get a response back that they were received. And I'm trying to remember, in this book it has the additional way that we can do, yes, okay. Because there's been a change in windowing just in the last couple of years. And it just appeared in this book, and that's when I first really encountered it. So we're going to send this whole batch of data. Now, what we've said is we've established a window size. Quite often you will see in examples that the window size they will work with is 3. What that says is we've got lots of segments down here. I'm just going to do a group of them. And what we've said is we're going to send 3 of them across. So those are going to come to here. Okay, so it sends 3. 1, 2, 3. So it sent 1, 2, and 3. Now, under traditional windowing, B, if it received all 3, will respond back. When it sends back, it will send back a message of 4. This sent 1, 2, and 3. What that says is when it sends 4 back to here, is it says, I received up through 3, and I'm ready to start receiving from 4. So now that machine will send the next 3, starting with 4, across. And hopefully all 3 of them get there, 4, 5, and 6. But what if only 4 and 6 actually arrive on this end? What's going to happen? Traditionally, in regular windowing, this machine would respond back with an acknowledgement of 5. It's saying I got through 4, but then I'm missing. So what this machine will have to do is then send 5, 6, and 7 across. And then, so it drops 6 because it goes, I don't know what that is. They have to stay sequential. Okay, so now it gets 6 again. So it gets 5, 6, and 7, and then hopefully that its response back is 8 to continue with that. And they continue on until the whole thing gets sent. Now, modern, this newest thing, there is a new special acknowledgement. So that was using acknowledgement. There is now a new acknowledgement which your book covers, which is a selective acknowledgement. This is SACK. And what it does is it can have a missing segment in there, and it will report that. So it will say, send me 5 and start from 7. So then you wouldn't have to send all the others that occurred after this, because with 3 there's only 1 more. But say we had a window of 100. If that was the second one in that case, we'd have all of these others. Well, it would be really handy to be able to say, send me 5 again, and then start with 100. And you'd save a lot of transmission and make your connection much faster. That's using the selective acknowledgement. Okay? Selective acknowledgement says you can have a missing packet or missing segment in there, not packet, and you'll tell it which the missing one and then where to pick up it to sending them all over again. I doubt that's very much mentioned on your test, but there could well be a question. That is new. Okay? The acknowledgement way that I showed you right here is what's traditionally the way it's done. This part is new with the SACK, and that this is a whole new way, and to make it faster on that than it was before. All right. The other part is, while it's sending this, the two machines have agreed on the window size, which is the largest amount one can send and that the other can receive, and before they want to send back. If you've got a poor connection, they may well, during the transmission, if there's a lot of things keep getting lost, they'll stop and renegotiate the window size and come up with a smaller window size. If everything's going through and there's no errors ever on it, it's a large file, machine A may request, say, whoa, let's stop and renegotiate this window size. It looks like we can even go a bigger window size and we'll get it done even quicker. And it can negotiate to increase the window size. So the window size will change during the transmission. But for your purposes, for test purposes, know that you negotiate a window size to start with. Typically, you're going to see that almost always in illustrations use 3, although in reality, they're not going to be that small, because it's easy for us to draw this little chart here showing how 3 works. That you'll negotiate a window size and then you work on through on it. But be aware it can be renegotiated during the transmission. Second thing is, know about acknowledgements. Acknowledgement, if you use just the regular acknowledgement one, what it's responding back with is the first segment to start sending when it sends this next group. And until this gets an acknowledgement on something, it does not send the next part. And this one's building it in order and is putting the whole segment, putting the whole data together from it, because it is transmitted across the segments. And then the selective acknowledgement, be aware of that you can tell it you're missing segments. I don't think you can send, actually you can, because you can tell it what you're missing, and then you can tell it where to pick up from, and that it will send on that one. And so it'll tell it what to send again. So the selective acknowledgement allows it to not have to resend segments that have been received. Any questions on that? But that got into flow control there about the window size and the acknowledging back and forth. I hope that makes it a little clearer for you. The other part to think about windowing here, when you're riding in a car or a plane or whatever, and you look out the window as you're riding down the road, and you look out the side window. What you see when you look out that side window is not everything that's out there. You're just seeing the part that window is showing at that point, and it keeps changing. That is where the term windowing comes from here. We're only seeing part of that whole file right here. I'm just using my finger pointing and y'all can't see that. So that would be like you were looking out the window in the car at that point. We've moved on down the road some, so now we see something different than what we saw before here. But that doesn't mean the world changed all out there. It's what we're seeing. And so that's where the windowing comes from. All right. UDP, low overhead, no reliability. So you don't know it got received there, but it's very quick to do on it. The other part is UDP, it may not be received in order, so it's the receiving machine's job to look at those segment numbers and get them put back in the correct order. So UDP is not going to deliver those in order on it, so they show you a little on that. And that's the chapter. We didn't do bad on that today. Questions for me? I'm not going to wipe this off the screen yet until I see if there's any questions about that. Y'all got any questions for me? Because we've run just over 50 minutes so far. So we're actually going to run about on time today. I hope that helps some in understanding. It helped me. Yes, Romulate. UDP is unreliable. You don't know if it got delivered or not. TCP is reliable. You know that everything got there because you just saw with where we just did this windowing process that we know. I figured it out. We know that every segment got there and that it was intact because when it gets it before it acknowledges back, it will double check those checksums to make sure that they match and that it's there. And then it'll do the acknowledgement back. So we know it was delivered. Not sure what's pre. I'm not exactly understanding your question, Whitfield. So you are sending it. It is sending back. It is sending back acknowledgments, which are notifications that it was received. But with the window and the first part, and I think you may have walked in after that, is the very first thing on TCP is we do establish a session. And it's just like making a phone call that we're going to send a sync signal, which is like calling the other number. The other machine's going to respond back with an acknowledgement where it's saying hello, and then the first machine will reply back with acknowledgement where it's saying hello, and the two machines both know they're talking with each other. And then the windowing occurs where it's transferring the data, and it's making sure the data is received because machine A is sending to B, but it's not. It could send the whole file depending on the window size established if it's smaller than the file size. But it sends it. It waits for an acknowledgement from machine B that says, I did get whatever that was. Now, if it's a big file, it's obviously going to do it by the window. So it sends first little bit of it. B sends back and says, I got that. I got that part. And then A sends the next part. B writes back and says, I got that, or says, here's where it always tells it where to start from. It doesn't say I got through. It tells it start from this number when you start sending again. So if it's missing something, it tells it start from the next position after the last one sequentially received. So in this case, 5 was missing, so I'll write back and say start with 5. Now, if it's using selective acknowledgments, which is the new thing to TCP, it will tell it what's missing and then says it can start from the end and continue on. It just has to resend the part that wasn't received. All right, any other questions for me? All right, I'm going to go ahead and close my share on this. And then I'll again. So now we're back on that. So I hope that helps with y'all on it. I know it helped me a whole lot when I was learning it, when it was drawn out on the board like on that, because just reading about it in the book gets a little confusing. Make sure also in the chapter you do learn those well-known port numbers that I told you need to be aware of. Okay, and there's other well-known port numbers also. I mentioned 3389 is remote desktop connection, which actually isn't a well-known port number. That's a registered port number because that's bigger than 1,000. But there's lots of others that are well-known port numbers that go up through 1,024. Also know those three categories. Well-known, 0 to 1,024. Registered, 1,025 to 49,151. And then private port numbers, which are ones you can use, that you will use from 49,152 through 65,535. Now, truth of the matter is, you can use any of those port numbers when you need to assign a port number to something on it. Just make sure it's not a port number that's being used for anything else. NetStat will give you a list of all of your port numbers, and so you can get those from there, and that you can choose appropriate port numbers to use. Any other questions? I'm glancing back up here through the chat. Okay. If there's not, I'm going to go ahead and stop this. I'm going to try to work on grading and some other stuff, and I've got to work on a couple of things I need to work on too today. But just in case you missed it, I did take Security Plus last Thursday morning, and I did pass the test. So that renewed my Security Plus certification for another 3 years from then, along with Network Plus is considered a lower level one to Security Plus, and that renewed my Network Plus for another 3 years also. So I did accomplish those. All right, I'm going to stop the recording.